Oil fields span thousands of acres. Pumps run 24/7. Failures in components like sucker rods, walking beams, and motor units can go unnoticed until production drops. Manual inspection is slow, expensive, and often risky in remote terrain. Computer vision changes this by turning ground and drone footage into automated monitoring. From detecting pump jacks in large oil fields to analyzing individual components for wear, CV models can flag issues before they escalate. In this video, I'll walk through a complete model training cookbook: how to prepare data, annotate oil pump components, train a detection model, and evaluate inference results. If you'd like to explore practical resources and hands-on examples, we've created a dedicated GitHub repository. It's filled with cookbooks covering computer vision, AI agents, and more. Link is in description. If you enjoy our content and want to see more, don't forget to hit subscribe.
Hello guys, welcome to this video on how computer vision helps in monitoring oil fields. Oil fields are huge, pumps runs all day, and checking every pump manually takes a lot of time and effort. Because of that, small issues in pump parts often go unnoticed. With drone footage and computer vision, we can automatically spot oil pump and check their movements and track parts like beam, motor, or counterweight. This makes monitoring faster, safer, and much easier. In this video, I will show you a simple step-by-step cookbook for training your own model. We will go through data collection, labeling, training, and at the end I will show a quick example of detecting oil pumps from a drone view. Before moving to our tutorial, can you give me the answer to this question? What is the primary advantage of RT-DETR compared to YOLO? The options are faster training on CPU, transformers-based global reasoning, requires no dataset, or last one, smaller model size. You can give your answer in the comment section. For first step in our model training, we have to collect some data on which we will train our computer vision model on. I have gathered some data of oil field, like this is a drone view of an oil field. Then this is a oil pump in action. Now we go to Labellerr and create a data set. As you can see, I've created a data set of these three video, and now you just have to create a project. While creating project, you have to provide it with 4 classes. So 4 classes, these are crank arm, beam, horsehead, and oil pump. Oil pump in whole general, and these three are the parts which I have to monitor. You can add more parts on your own if you want. I'm using these three as an example. Let's annotate it. Now our horsehead is annotated. Now crank arm. This has been annotated. Now the beam is here. So, and the oil pump. Now our first frame has been annotated. You just have to run SAM3 on the whole video for all the objects and wait for a few minutes while SAM3 annotate whole video for you. Let's wait for a minute. After a few minutes, your annotation of the video look like this. As you can see, using just one frame, you have annotated your whole video frames. So let's get to our next step. For the next step, you have to export your annotation. So as you know, there are 4 classes I have used and one for bounding boxes. So for this video, I am going to export only bounding boxes, and this video only have bounding boxes. So I just export the B box, and the only class I will export is the oil pump. As you know, it is the bounding boxes. Now just export it and create an export. It will start your export. Now just as same, you can export the whole for all the classes for segmentation. Now you got to export one for only bounding box classes and one for segmentation of all classes. With that, let's get to our next step. When it's completed, you just have to download it from here. So when your annotation export is downloaded, it will look like that. You have to export one for bounding boxes class only and one for all the classes of segmentation. Now let's get to our next step. In next step, you have to convert those classes to YOLO format. So just clone this repository. I have already done that. It will look like this YOLO fine-tune utilities. From that, you have to convert, you have to import a function from YOLO fine-tune utilities, video annotation, YOLO converter. The function is convert to YOLO segmentation. Using that, you can convert your annotation into YOLO segmentation style format. So you just have to provide the annotation JSON, video directory, and output directory name. Now just run this. Similarly, you have to use this function to convert your annotation into YOLO bounding boxes style dataset. After that, you will get two dataset, one for bounding box training. The difference is here. As you can see, its train have only the bounding boxes, and for the segmentation, you will got the whole segmentation mask. This is the main difference between bounding boxes and segmentation. Now, after that, you just have to clear your memory like I do. Let's run this. Hmm. As you can see, I have now free VRAM. Now let's start our YOLO segmentation model training for segmentation class only. I am using a YOLO from Ultralytics and the model is YOLO11s slash segmentation for segmentation training. So you just have to use this model and then use dot train, and in that you just have to provide data equals to segmentation data set, which is our this data set, and its data.yml part like this. You can comment it out this part. Now with that, your training will start. So first of all, you just, as you can see, our training has been started. I will stop it as I have already done my training. It took me around 1 hour to run for 50 epochs on nearly 408 images. So it will look something like that. Detect, here is our predict, here here is our train, here is the weight I have trained my data set on. This is the data set which is fine-tuned for oil pump detection. Now let's get to our next training for, this is for segmentation, sorry, this YOLO is for segmentation. So this is the model which I have trained. This is best.pt for oil pump detection. Now for our next step, you just have to use similarly import RT-DETR and use this RT-DETR model, then use the argument, use the function method dot train to train this model for oil pump detection. You just have to provide the bounding box dataset .yml file also here. With that, you just have to run it. After running it, you will get a detection model for RT-DETR. Here is that. Now after it is done, you just have to load your both model, detect model which is for bounding box detection, and a segmentation model for segmentation of various parts of an oil pump. Now let's run our inference and see the result. So Let's see the result. As you can see, it detected all the oil pump in our oil field video with a drone view. So let's get to our next step where we segment each part which we have annotated using our segmentation model. So let's run this and see the result. Let's see the result. As you see, both video inference result was great and our model performs in real time. Now you can create your own computer vision model for uh, oil field monitoring or oil pump segmentation. You can say what you like. You can create another similar computer vision model for your own gains. To create similar model, you can check out another videos like how to fine tune YOLO on custom dataset, or like how you can perform object counting using computer vision. Please check it out.